recorded. Okay, so last year I decided to make it a platform where I'll be able to help others because along with my work, I have been a trainer with a lot of institutes such as Simply Learn, Edureka, Intellipat, Janbask. I have been a trainer with them for a very long time now. So part of my training, I have seen everywhere a constant issue, or the students that I used to teach, they have faced that issue constantly, where they get trained but they don't get placed. And the other thing, they get trained, but when they actually do, it's not project oriented. It's not real hands-on training. Somebody comes and basically, teaches on a presentation. Looking at all those issues, and I also have faced a lot of issue hiring the right set of candidate or right set of talent throughout my stint. And currently also I have a consulting firm where I actively hire, uh, but the problem is getting the right talent or right set of people who will be able to complete the job in the agreed amount of time. So with that challenge, I decided to start or convert Virtual Box just from a blogging platform or a blogging website to a full-fledged learning platform where we will just focus in three areas. DevOps, it's when I say DevOps, it is actually DevSecOps covers everything, but our DevSecOps is a GenAI integrated, where we will teach you how to integrate GenAI in each step of your, or into your day-to-day life. It's not AI or GenAI is just not about asking ChatGPT, give me a script, but how you will automate, most of the task using GenAI's API, where you will integrate your GenAI's API to your Jenkins GitHub action, and how that will turn out, or how that will basically, go ahead and automate lot of tasks that you repeatedly do. You use N8N workflows, a lot of other stuffs also, apart from just the chat gpt or GenAI, that will be teaching part of this. And this DevSecOps, what we are going to provide, it will cover SRE part, it will cover platform engineering part, it will cover DevOps, and then security. We have multi-cloud offering. Part of this course itself, we will cover AWS and GCP. As of now, we are not covering Azure. We'll just cover AWS in to the full extent, where after completing the course, you can easily go ahead and pass solution architect exam without any help. GCP, however, will not be to the complete extent. GCP will be only whatever is required, that much will be provided, or the core services of GCP, such as network, your instances, security, all those core services, three or four or maybe maximum five services, storage, maximum five services will cover of GCP. And then we'll go to open source DevOps, where we'll learn about, CI/CD. We'll learn about security in CI/CD, what is DAST, what is SAST, and how you automate, those scans in your, or part of your, CI/CD. Apart from that, or right after that, when you run your code or when you run your product in AWS, you also face a lot of challenges in, or lots of issues that comes in the product itself. How do you debug that? How do you monitor your product? And what and all different types of monitorings are there, such as or what and all different metrics are there, such as business metrics. For, let's say, you are saying your CPU, there is a spike in CPU, but how does that spike in CPU matters to a CEO or maybe a CMO? So that correlation we will also teach you, where we will also take a complete observability or AI, sorry, SRE plus AI or GenAI integration, where we will showcase you how exactly you can go ahead and troubleshoot, or how exactly you can take help of a lot of MCPs or agentic AI that is available today, and how that will enable you to troubleshoot issues faster, or in first place, it will not allow issues to happen by proactive. measures, you should stop issues from happening. That is what SREs do. And then platform engineering, where you will learn Python and Go, which will enable you to ensure that you are able to create internal developer portals for enabling developers. So now the world has slowly moved from DevOps, where DevOps used to be enablers for developers. Now it is platform engineering, where you build platforms through which the developers get enabled. But you don't do that, support, or you don't get to play the support function anymore. The world is evolving. That's where our course is designed in such a way to ensure that you guys also, once you complete, you are evolved with the world and you are able to meet the current need of the market. So that's about me and the organization. And then along with the GenAI integrated DevSecOps with AWS, we are also providing GenAI integrated data platform engineering with AWS and AI/ML, which is nothing but your data science, data mining, and bit of ML. So that is the three areas we are focusing, or three courses we are providing. So now let's open it up for a round of introduction from you guys, and then we'll slowly start. We'll start with the workshop and what and all we'll be doing in the workshop. Yeah, starting with Bijli.
Hello,
Yeah, go ahead, Bijli.
am I audible now?
Yes.
My name is Bisley. I am from Northeast Suburb. So I'm working as in data analysis now, but I'm interested in studying AWS and DevOps. So it's a new field for new technology for me, and I have no such prior knowledge about this. But still, I have studied like all the AWS services, and then like a little bit of Git, Terraform, and Docker. So yeah, so here I'm for like knowing it better
Great.
if I can do it on.
Great. Next, Divendu.
My name is Dibyendu Ghoshal. I am an AMI electrical engineer, and after that, I have completed PGDBM, postgraduate diploma in management. Specialization was system and supply chain management. And also, I have done BSc from Calcutta University. And I have started my journey in the IT field in the year of 2001. And at that time, I have joined as a project team in CMC Limited. And as a system of a Unix system administrator, I have worked there near about 7 years. And in course of time, I have get opportunity to work in another organization. And so far, I have changed 7 companies till date. And after that, I have also changed my domain to network, and from network to network security. Right now, I am working as a senior network architect, where my responsibility is within the activity of the network designing, network implementation, and also the network security and the vulnerability test, all those things. And my intention to inquire about this course is to change my domain, because the network infrastructure what I am right now working is not in vogue right now, and the network system has been gradually changing, and it has last 5 years it has rapidly changed towards the cloud structure. And you may be aware of the SD-WAN, and SD-WAN,
Yeah.
it has a great and rapid implementation is going on in the small and the medium scale companies. But I am working as a network senior network architect in the project of National Informatics Center, the only IT organization of Government of India. Actually, they are playing a role of ISP like. So all over India and all over the world, a few ISPs are the giant player in these industries,
True.
and they are the scope of opportunities is very less, and the similar type of actual technologies they are implementing all over the world. But as they are the scope of getting opportunities is low, for that reason I am interested to change my domain again to the system. And in the meantime, what happened when I was worked as a system administrator at that time, the on-premises data centers there have no virtualization concept. But as the invent of the virtualization, the most cloud-centric technologies are developed based on the virtualization, and I am a little bit of test from that technology, and now I am interested to DevOps and DevSecOps or the system reliability engineers, and I need also some assistance who wherever I have to take training. That's all from my end.
Got it. Got it. Great. Uh, Next, Munib. Okay, I think Munib is away. Next, Sasi.
Hi, good afternoon. My name is Shashwat. I'm currently working as a Microsoft Exchange administrator.
Mhm.
So basically, I'm interested in multi-cloud DevOps.
Great.
Yeah,
Okay. 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 I think we have done with the introduction. Let me just share my screen and bring up. Uh, so what we are going to do, part of this workshop is this is just a this in 2 hours possibly we cannot understand entire DevOps on its own, right? So what rather than that, what we'll be doing in these 2 hours is just take a small application or a demo application which is available already in the market, and then just deploy that application to AWS Kubernetes. Okay. So for this exercise, we will be taking EKS, which is a managed Kubernetes service of AWS. So we will understand Kubernetes in very in-depth part of our course, or when we exactly get into the course, we will understand what is Kubernetes, what is Docker, uh, I mean, everything about it or all the aspects we'll understand. But part of this, workshop will be, I'll give you a very high level glimpse, which will make you, or which will, help you understand what is Kubernetes. And then part of our the regular course, not this workshop, part of the regular course, you will get to create an application, create multiple applications. Actually, 2 or 3 projects will be there, so you will get to create an application and deploy the application to multiple environments such as ECS or Docker Swarm, Kubernetes. You will understand everything about, or a very in depth about, what is containers, how to do container security, how to do runtime security, what is container orchestrator, what is VM, what is bare metal. Everything you'll understand on the infrastructure side. You will get a complete glimpse what and all things has to be required for a DevOps engineer to complete his task. But before that, let's just go ahead and create a Kubernetes cluster, which we'll be using to deploy. So this is auto mode. I'll not go ahead with auto mode. Why I'm creating now before I explain you, because it's gonna take time. By the time it gets created, I will give you a complete picture of what is Kubernetes. But before that, let me just create this because it's gonna take 15-20 minutes time. It's okay. Security groups are not required. I'll just go ahead and create this. Okay. So now here you can see lot of add-ons are there. I'll explain you what are all these add-ons, but you have to select whichever add-ons are required. For example, if you need a integration among your Kubernetes cluster and then EBS volumes, EBS is block storage of AWS, then you should select this. Otherwise, you don't have to. Okay, but for this exercise, it is not required. But when we are going for the class where we'll have to deploy stateful applications, you need this. And similarly, for EFS, this driver is required for EFS. But for this workshop, we don't need any of this. So I will just go ahead and just look at what and all things I need.
Hello.
Yes.
I can only see the virtual box, tech box Google page.
Is it? Okay. Is it visible now?
Yes.
Okay. I had shared the other screen. Okay. So I'll not select anything from marketplace, and that's all. Everything that I am selecting, all these add-ons, most of these add-ons would require a role. In my case, I have already created the role, or the roles are already created. If you don't have the roles created, you can just click on this button. It will take you to the IAM window where you will get the option to create the role. So it is already pre-populated. You can just go ahead and next, and all the policy that has to be selected, it is already selected. So you can just go ahead and do next and just finish. So and give it a name. So it will create the particular role that is required. But in my case, as it is already created, I don't need to create it once again. It is already created. I have just selected it. It is again auto selected. I am not doing that also. Okay, I'll go ahead and click on create. So it's gonna take a bit of time to come out of creating stage to available stage. And we cannot do anything until it comes to available stage. So now let's understand what is Kubernetes. You might have seen, when you think of computer, the first thing that comes to your mind is laptop and desktop. Then why we need servers? The difference in between your personal computer and servers or a commercial or enterprise grade computer is your by default they all work in the same principle. There is no different in the working principle, but the capacity that your personal computer can have, that is much lower than the capacity of a enterprise grade computer. Now in enterprise grade computer, you have, it's all started from tower servers, and then now you have blade servers. In between there is a rack server. So now all these servers, they perform, they provide a lot of functionality such as hot swap, such as a lot of other features. But there is lot of there will be a lot of task required or a lot of extra man hours required to manage those servers. That is why you have cloud. So think of cloud as a example. Let's say you have option to buy a car versus renting a car from Zoom cars or something similar. So now to buy a car, you have to pay the upfront price of the car. You have to pay the insurance. You have to have a space to park it, and you also have to do regular maintenance, oil change, wear and tear of tires, and a lot of other stuff, right? So now think in this way: if you have an option where you don't have to invest all that and still you get to ride a car for the amount of time you want, because you don't need car 24 by 7, right? You might be going to a particular place and you need a car, so that you can just take a round trip, or maybe take go from point A to point B and then come back to point A. So Zoomcast works in very similar principle to what cloud does. Cloud provides you a mechanism or uh, a methodology where on-demand supply of compute resources are provided to you, and you just pay for the amount of time you consume that resources, the amount and the capacity. You, let's say you consume one CPU, you just pay for one CPU. You consume 10 gig of memory, you pay for 10 gig of memory. You consume 100 gig of disk, you pay for 100 gig of disk. So that is on demand supply of resources, and you also pay on demand, on a on demand basis. You don't have to park your money, buy a server to basically run an application. Now with that, how cloud is able to achieve that, that has been achieved through virtualization. Now what happens in virtualization, you have a single server. Virtualization acts as an abstract layer on top of your operating system or the hardware, where it allows your hardware to be shared. And by sharing you can create multiple smaller version of the same hardware. Now let's say you have a single CPU or single processor, it has 9 cores, but for your application to run you don't need 9 cores, you just need 3 cores. But rest of the 6 cores are being not utilized, it is wasted. Because now if you are running a Python application in a VM, you cannot run a Node.js application, because there will be conflict in the environment variable. There will be conflict in the runtime. To address that, you have VMs. But the problem with VM is VMs are very large. The resource sharing exactly doesn't happen, because the VM or the operating system which VM basically works on, that is also very large. That is as good as having your server as bare metal only. So now to solve that problem you have containers. Containers are lightweight. Containers, in case of one VM you can run 10 containers, okay, because containers are lightweight. For example, one let's say Ubuntu operating system, in your VM it is 4 GB, in container it is 200 MB. Okay, so that is the difference. It is exactly like not 1% or maybe half 0.5% of your total size. So now containers, if you think of
Mamon,
containers,
Mamon?
Devendra, you are saying something.
No, 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 no. Sorry, sorry.
Okay, so now if you think of containers, containers are like or take another example. Let's say containers are like cars. You might have been to all of you might have been to traffic signals, right, where you see a lot of cars in traffic signal, and then when traffic opens they go in a particular direction, or they go wherever they have to go. But think of these traffic signals are adaptive signals. Now in Bangalore they have this adaptive signal, and then multiple other places also they have this adaptive signal. What this adaptive signal does is, whenever there is a rise in traffic in a particular area or particular signal, it automatically senses the traffic, or the change in the traffic pattern, and it opens the floodgate, or it opens the traffic signal, so that the traffic, or the sudden surge in the traffic will get reduced. So Kubernetes is pretty similar. Now your cars are container. Kubernetes is your traffic signal or the adaptive traffic signal. The Kubernetes manages your containers, or any orchestration platform such as Kubernetes, Nomad, Docker Swarm, Apache, Rancher. They all work in the same principle. They manage or they orchestrate your Docker containers. Whenever there is a traffic for a specific service. Let's say you are running two containers, it will automatically scale that container numbers to four containers, which is a vertical scaling. Sorry, which is a horizontal scaling. Okay. So it will, vertical scaling is where you increase the size of the VM. Horizontal scaling is where you add more and more VMs. Similarly, here you can do both vertical scaling also, horizontal scaling also. Part of the course, you will understand when to do vertical scaling or the particular use case for both the scaling requirements. And how do you basically identify, or what are the metrics that you look into, which basically decides when to scale, when to scale up, when to scale down. All those things you will be understanding part of your the regular class. So any questions on this, guys? Anyone?
Yeah, is this any automation tools are available to get information whether to scale it down or whether to scale it up? Uh,
It is
in Kubernetes?
automated. It is
Okay.
automated. So there is something called as HPA. There is something called as VPA. Okay. HPA is horizontal pod autoscaler. VPA is vertical pod autoscaler. That in that itself, you will be defining when to scale, when to scale up, when to scale down. Okay, so now let's say you are saying when two of your containers in a particular service, let's say you are running with two containers. If both the containers run about 90% of CPU, you add two more new containers. And at the same time, you will be saying the min and max you will be basically defining. So at the same time, you will be saying when they go back below 50% or below 30%, scale down one container. That means it will delete one container. Kubernetes does that automatically. You don't need any separate automation tool. What you have to do is you have to define a HPA, horizontal pod autoscaler.
Can you show an example of that HPA?
HPA, not now, we'll be seeing in the actual class.
Okay.
You'll have to write that HPA actually. Okay, so now this cluster is ready. What I'll have to do, I'll have to add nodes to this cluster. Okay, this is gonna take some time. So how Kubernetes basically work? Okay, now you have understand what is Kubernetes or what Kubernetes does, but how it works. Kubernetes works on a principle, called as control plane and then worker plane. Okay, Kubernetes has two components, two major components. You have control plane, you have worker plane. In control plane, you have etcd, you have Kubernetes API, you have scheduler, you have controller. Okay, this API is responsible for all communication to your control plane. Okay, if you want to say anything to Kubernetes, if you want to send any information to Kubernetes or any command to Kubernetes, or if you want to receive any information from Kubernetes, that is one way in, one way out. That is your Kubernetes API. Now, etcd. Etcd is your data store or database inside Kubernetes. Okay. This is a data store. This is an open source data store. You can use this etcd in other places also. Now, your scheduler. Scheduler is responsible for placing the pods. Scheduler understands all your worker nodes, and then it basically, wherever it sees a worker node is free, it goes ahead and place the pod in that particular worker node. Now you have controller. Controller is basically for all your worker nodes to get connected with Kubernetes or join the master slave concept and get controlled by the master. You have controller. And for your AWS or GCP or Azure, for the cloud control part also, you have controller. That does, this will have two controllers again, one for all your worker nodes and one for all your clouds. That is called as cloud controller. Okay. Load balancer, anything that you have to attach, that gets attached through this controller. But the entire communication happens through Kube API. So now on this side, on the worker side, you have Kube, kubectl or the client, which basically talks to this Kube API. Okay. And then you have Kube proxy, Kube DNS. Okay. This two talks to your controller and gets the DNS. Let's say you have a Route 53 DNS. This queue proxy or queue controller will talk to this queue proxy will talk to controller. This controller will talk to Route 53 and get your DNS resolved. If it is not internal, if it is internal, it will talk to etcd. It will get it resolved if it is there in etcd. Similarly, you have queue proxy. What proxy does is forwards the traffic. So now let's say you have a service to which traffic is coming. Now that traffic will always come, controller will always send the traffic to queue proxy, and queue proxy will send to the actual pod. So next, what is pod? Pod is the smallest component of Kubernetes, where actually you host your application or the container which you package and which runs inside Kubernetes, that is called as pod. Clear? Any questions on this?
What I realized is the POT is point of delivery. Is it the abbreviation of POD?
Yes. I mean, it is not exactly a point of delivery. Uh, it is something else. I'm also forgetting that, but it is actually, it can be a single container. It can be a multiple container. Okay, a pod can be also a multiple container. From
Okay.
Kubernetes angle, that is the that is the smallest component. What it does is you can club. Let's say you have a particular application which needs a startup container also. So both will work together. Or if you have a concept called as sidecar. What happens in sidecar, that you inject another container along with your application, and that container is short lived. Short lived means it will leave only for first 30 minutes of your container or your application running, and then after 30 minutes or maybe whatever time you define, it will exit. Okay. So
Mm.
that, in case of the sidecar also, it will become a single pod. Pod means whichever the smallest version of your application running in Kubernetes, that will be pod. I will have to, what is the definition of pod, or what is the full form abbreviation of pod? It might be point of delivery, I'm not sure. It doesn't have a full form actually. It's not an acronym. It's the name actually. Okay, so now the node is ready. How do I connect to this Kubernetes cluster? You have multiple ways to connect. The simplest form is you can use kubectl is the client to interact. Okay, I have in my laptop, I have already installed kubectl. Okay, so in case you want, you can also install kubectl to, or I mean, you will obviously have to install kubectl in your laptop to connect to the Kubernetes cluster once you create it. I'll just have to stop share. I have to look at my credential. Okay. Hopefully my screen is visible once again. Okay. So now I can, I have updated the context, or I have let my system or my kubectl know that whenever I'll be connecting, I'll be connecting to this cluster. This is my cluster name. This is the region where I have created the cluster. And this is the credential that I have used to connect to the cluster. Okay. So now what I am using is K9s. It is again a open source dashboard to connect to your Kubernetes cluster. As you can see, I have already connected to the Kubernetes cluster, and I can see, two nodes that are ready. I can go to all my pods. Let's take a, small 5-10 minutes, 5 minutes break, and then we'll come back and deploy one application using probably Nginx as the ingress. You will understand what is ingress, and I will tell you how the basically work the packet flow works. Okay, let's take a 5 minutes break and then we'll come back. Any questions so far? Anybody? Dipendu, Bijli, Munib.
No, it's okay.
Okay, let's take a 5 minutes break and then we'll come back. Okay, I'm back.
Hmm? GenAI. তাহলে এখানে করতে হবে। You are muted.
Oh, my bad. Okay, what I was saying is, if I run this kubectl apply hyphen AWS auth hyphen CM, this will provide access to the other user that is mentioned in this URL, which I showed in my AWS account. But for this exercise, I don't have to provide. I'm just showing this has to be done when you are running in enterprise mode. Okay. And you will have to ensure that RBAC is done. So in Kubernetes, you have different groups. Depending on whom you have to provide access, you will have to select the group here. So that will ensure that that person is getting only that much access. because RBAC is very mandatory in Kubernetes. Otherwise, by default, whenever you can't provide somebody read-only access, you can only ensure that people have access to certain resources, and they don't have access to some other resources. So that resource has to be namespace specific. Okay. So this is the way to provide access to Kubernetes. Now you have to play with the group. You will have to create different groups in Kubernetes, and then each group will be tied to a particular namespace, and then you provide provide them access in this auth. So now this particular set of this thing I have created for one of the previous demos, but right now we will not go ahead and use the same. We will go with Nginx controller. This is with Istio service mesh. But even before we set up Nginx controller, we'll have to install the AWS load balancer controller and see whether it is working or not. The load balancer controller, as I mentioned in the previous or maybe 15 minutes before in the architecture part of Kubernetes, the load balancer controller will enable our Kubernetes cluster to talk to AWS API and create load balancer, manage load balancer on behalf of the Kubernetes cluster. But before even we do that, we will have to ensure that the cluster that we created is having a OIDC. So OIDC is going to be the authentication mechanism. Okay. So I'll have to change the name. The name is okay. So this is the OIDC URL for the cluster. So I don't need to run this because the OIDC ID is the last part of the URL. So I'll just capture it here and I will replace it here as well to basically list or to check if this OIDC ID is connected in the IAM. So as it is not, as it is not connected, I'll have to run the below command, this command to create the OIDC connector in the IAM. And to get this thumbprint, you will have to run this, command to get the thumbprint. UMB. Okay, so I got the thumbprint now, which I'll put it here. And then I'll create the OIDC connector. Okay, so once this OIDC connector is created, I'll have to create a policy, which will be used for creating the load balancer controller. Now, if I will have this policy, we'll just go ahead and change the policy a bit, but this policy is already created. So why I'm looking at this policy JSON is basically if anywhere it is mentioned about the Kubernetes cluster, we'll have to change that. As it is not mentioned, we will not have to change this policy. We'll just look at the trusted. So this role only we'll have to change, nothing else. Okay. I'll just replace this YDC URL and export this. So my CMD knows by default which is the OIDC URL. Okay. So now I'll just run this to create the trust policy. This is already present, but I'll have to modify it. So I'll just run this. And let's check whether it is modified. Yes, it is modified to the new, OIDC URL as per the new cluster. The role is already created, but I'll have to update the role to basically take the trust policy. If I'll go to the role, let me go to this role. You can see. So here in this, it is pointing to the old OIDC URL, right? So I'll have to just update it. Okay. And why? Okay, assume policy. So this is not identifying this command. Trust policy JSON. Okay, so we'll do it manually. Okay. The policy is updated manually, but this we can troubleshoot this why this update policy is not taking the file permission or the policy document part. That should provide the fix. I mean, once that fixed, it should work. Okay, so as the policy is updated, we don't have to do this. It is already done. If you're doing it first time, you will have to attach the policy with the role. Okay, so we'll just skip this part. It is already attached, as you can see here. It is already attached. We just had to change this trust relationship, which is done now. We will go to the next page. Now we will install the cert manager. Now next, we'll go ahead and edit or modify the EC2 instances. So this EC2 instances, by default, the HTTP metadata is disabled. So we'll have to edit this EC2 instances to ensure that HTTP endpoint is accessible. Otherwise, your Kubernetes cluster will be not able to reach this EC2 instances, or Kubernetes API will be not able to reach this EC2 instances. And when you are creating a load balancer, inside load balancer you create a listener group. So these nodes should be attached to the load balancer, or the node balancer's listener group. Basically, these nodes would be attached. That's how the traffic will flow. Okay. So now we'll go ahead and install the Nginx controller, for which I'll be using Helm. Okay, sorry, I have to install the AWS load balancer controller first. Just 1 minute. Okay, so we will do, to deploy this, we'll have to create the service account. So this below command will basically create the service account, which we will have to run on our well, okay. So now this service account is created. How do we verify? We go to our Kubernetes cluster, which namespace it have created is kube system. So we go to the namespace. I'm writing ns, you can write namespace. I'll go to the kube system namespace and I'll ask for service account. Okay, you can see AWS load balancer controller. This is the service account we created. It should be visible here. 35 seconds ago, it has been created. If you want to look or if you want to match, you can just do a describe. It should provide you this annotation. If this annotation is fine, then it's gonna work. Otherwise, it will not. Okay. So now next, what I will do is add the Helm repo for the load balancer. It should be already existing. I'll do a Helm repo update. As it is already existing, I'll do a update and fetch all the changes to the Helm repo. And Helm is basically a repository. How you have GitHub, Helm is also similar, but only for installing things on Kubernetes. Okay. Next, to install, this is the below command where I will replace this cluster name this region with AP South 1, this cluster name with our cluster name. So this will work, this dollar symbols will work if I would have set it in my, or if I would have exported this value, this will work. Okay, so this VPC ID, I can get it this way, or what I can do is simply run this command, get the VPC ID and just put it there. This is the VPC ID. I'll just put it here. Oh. It is installed. Okay, this service is installed. We will go ahead and look into the logs of that. If you see any error logs here, that means it is not working. If you see a reconcile error log specifically inside the pods of the AWS load balancer controller, that means it is not working. As we can't see any reconcile error logs, it is absolutely working fine. So now just to verify, we will run this. Yeah, you can see the two pods are deployed, and if you want to still see the logs of those pods, so these are the pods actually. This is the service, or this is the deployment, and these are the pods. Now let's create a demo application, or let's create a namespace to deploy the demo application and deploy it. Next, I will deploy a demo application, which is a Google sample, which is available publicly. Okay. So two applications I'm creating, and then I'll expose them by a service. I'll be creating a service. Okay. So in class, in actual class, you will understand what is service, what is deployment, what and all different native resources of Kubernetes, what and all different uh, external resources of Kubernetes, which you still can use. Okay, now we can check if ingress is created or not. It is created for the demo application. Okay. Now let's test the ingress. It has some issue. It is not able to find the IP address. So the possible issue can be this subnets that I have by default, the public IP assignment, I have not enabled it. So I'll have to go ahead and troubleshoot that. This public subnets I have selected, but this public subnet I might not have enabled the. It is there. This is also there. Then if that is not the case, it will be a tag case where it is able to find some, it get placed on a particular tag, but it is not able to find that tag. So to which Okay, so the problem, the problem is this particular part. If you look at all the tags, it is having my cluster. Okay, but however, we have created the cluster, right? The cluster is having a different name. That is why this problem came. So we'll just change. Okay. So once we do this in all three subnets, it should work fine. It will come. We'll just redeploy this ALB. That should. Okay, now it is working fine and our load balancer is also created. So we'll just verify the load balancer. You can see the load balancer is created. If I call it, I should be able to get a response. Okay. No, it's not resolving. Let's take it to a browser and see. Something else is going. This has something to do with the DNS. It takes a little bit of time generally. Let's see if that resolves. It is active. Now it is active. It is not giving that previous error. It should work now. Yes. As you can see, I mean, it's just a basic app. It's not showing anything, but if we deploy something, it will show here. But as you can see, we are able to successfully deploy the application that we are running in our Kubernetes. I'll just go to the application. So it is basically showing this applications. And this is the service. And this service is a cluster IP service. It is an internal service. But I'm exposing this service through a ingress controller. That means the traffic flow is something like this. From my laptop, this is my laptop. I am hitting the load balancer of AWS. This is hitting the ingress resource of Kubernetes cluster, EKS, and then that is going to the service. Here, couple of things to look out is this service will have a layer where it will go through the kube proxy. Okay, this is load balancer or LB. This is ingress. This is proxy. This is service. This is my laptop, and this is internet. Okay, guys. Any questions on this?
This visual code is completely new for me. I didn't get all these things much, but yeah, maybe
This is just a 2 hours. I can't give you the entire picture, right? In 2 hours, only this much I can show you. But you will eventually understand what AWS. I mean, all the codes that I have put, that is nothing but AWS API calls and Helm API calls. Helm is a repo manager which works with Kubernetes. Some commands of Kubernetes you will have to learn. That will I'll be teaching part of the course itself.
No, what my thing is, when I went through the Udemy class, no, in there, what I saw that we have to work on console. Now here, when I'm joining the this workshop, it is like completely code. So do I have to write all the codes manually for any server, or it making easy to instance and everything?
To be very honest, uh, if I mean it is organization to organization, 90% of organization they will restrict you to do things at CLI. I mean on the console, AWS console. Okay.
Mhm.
Uh, we also did couple of things in AWS console, but while going into codes, it will be through Terraform. It will not be through console. Okay, Terraform is the infrastructure as code
Yeah.
principle. Either Terraform or there is something called as Polomy, or there's something called as
Cloud formation.
Pontefu. Grafana is a visualization tool. We'll go through
No,
Grafana.
cloud formation.
Yeah, cloud formation. Either of it will go through. So you will also understand from how to manage infrastructure from just from GitHub, not anywhere else.
From GitHub, we have to pull all these things.
Yes, everything will be stored in GitHub. You change whatever you have to change in GitHub, and then that gets transmitted or translated into actual infrastructure changes.
And that GitHub, in the GitHub, we have to write the code, or the developer will write it already and we just have to deploy.
No, no, no. You will have to write the for infrastructure. You will have to write the code.
Okay. Mm. This for me as of now, looks very like code things and all.
That I'll be teaching part of the class. I'll be teaching you YAML. These are not codes. These are declarative pipelines. Okay. So this declarative pipelines is written through YAML. What you have seen is yet another markup language, and everything that you see here, this, or let's say this, it's all YAMLs. Okay, so you just have to understand, like, this AWS is nothing but AWS API. When you are saying AWS, it expects something, or AWS API expects another input. So that input can be IAM, that input can be EC2, that input can be EBS. And then once you put IAM, that also expects something. So here it can be attach, describe, update, create. So that part I'll cover you. You don't have to worry about it.
Okay. Okay, then. Thank you.
Yeah. Divendu, any questions?
Actually, uh, about the structure of Kubernetes, I am totally, I have no idea. And whatever you have explained,
Mhm.
uh, you did it practically. Uh,
Mhm.
Everything gets jumbled up. I cannot follow the steps because if there be any flow chart type that whenever some Kubernetes configuration is going on through step by step, it will be a little bit of we can be
Yeah,
connect
yeah.
all
See,
these
part
things.
of the codes, in actual, this is just a workshop, right? In 2 hours, I can't cover
No,
everything.
no,
It's
no.
3.5 months course. So when we are doing it in the scale, right, everything will be covered. Okay, there will be particular flow structures, how everything works. Everything is, everything is already documented, and you will
Mhm.
get everything. So entire hand holding, entire understanding from conceptualizing to hands-on, both part you will get.
So, oh yeah, hands-on parts. Can you explain a little bit of because all these things are totally practical oriented, and do we get the adequate opportunity to hands-on experience on the Google platform or the Azure AWS platform free?
Yes, yes. You will get more than adequate, where we will, initial 15-20 classes, we will
Mhm.
just go to set the baseline.
Mhm.
Okay. Set the basic understanding in right place. Once that is done, we'll start with a project mindset, that we will, first develop and deploy a e-commerce application. Second, we will go ahead and develop and deploy a, let's say, a real-time messaging application. Third, we'll go ahead and develop and deploy a streaming application. Like that, we'll do 3 or 4 projects we'll be doing. Okay. And how you mimic, let's say you have developed and deployed a e-commerce application. Now,
Mhm.
majority part of e-commerce application is your scalability. I'll also teach you how to basically mock that scalability. Okay, how you will be able to create that surge, artificial surge. I mean, actually, on our platform there will be no users, but we have to
Mhm.
mimic that there are 100 million users. Okay, so that part also I'll be covering. Bit of QA also will be covered in the security when you are using JAP proxy or SemGrape or SonarQube. Other than SemGrape, JAP and SonarQube, they are used for QA also. They are very good QA tools as well. So we'll understand from QA aspect also, when when you are developing an application, you are deploying it to the lower environments, how exactly we will have to perform QA or the automated testing, Selenium based automated testing, how we'll have to perform, that will be also covered.
কি হলো ওটা? কি করবো?
Hello.
Yeah,
QA means I didn't
quality
get it.
assurance. So
Okay.
it is, essential part of software development, or SDLC, software development life cycle, where any program that or any application that you are creating, that has to be benchmarked, that has to be tested, right? So let's say you are adding a feature, whether the feature is going to work or not when the application is actually online. How do you define that, or how do you identify that? Even I mean, you cannot possibly in a real time scenario or in a company scenario, you cannot take the risk of deploying the application and then figuring out, okay, this is not working. In a company or in an actual use case, you'll have to deploy before even deploying the application, you'll have to ensure that, okay, the application will work fine when I deploy. You'll have to get into that mode. So that mode, that assurance will be provided by QA. Software testing, if you guys know. So the security testing that we will have, the DAST or dynamic application security testing, or the static application security testing, it will be clubbed with the QA part also. Anything else, anyone? Devendu, Bizli?
Uh,
No,
no, nothing from my side. Whatever I had doubt, I asked. That is what my main concern is. Ki what I went through is like all theoretical part. Now, when I'm seeing these things, it's fully coded part. So that's what like making me like overthinking and overwhelming now as of now.
Yeah, because in Udemy, you will not get this depth, right? In
Yeah.
Udemy, or even I have I have been a trainer with Simply Learn. I don't provide this depth in Simply Learn. I have to stick to their content. Okay, here I'm going very in depth in the workshop itself, and you can imagine in the class it will be very in depth, because the whole point is not to just teach you, but rather to make you a successful DevOps or SRE engineer. And the only way you can succeed is if you are completely, having a very in-depth knowledge. Otherwise, again, you will learn from me and then you will go, but when actual work will come, you might be not able to perform. Okay. Uh, if no further question, then we'll call it a day. Um, Tarun will get in touch with you guys and discuss the further steps.
Okay.
Yeah. Thank you.
thank you very much.
Thank you.